Hello, this is a presentation on Galveston Specialized Construction and Infrastructure by Joseph Fu, John Paul Navarro, Jimmy Stewart, and Gavin Webster. So one of the main reasons why we have this special construction and infrastructure is because of corrosion. So what is corrosion? Corrosion is the natural degradation of metals in the presence of harsh environments, which is usually referred to as rusting or corrosion or oxidization. This process is facilitated by the presence of oxygen and acids, water and salts, and ions as well. And we can see in these pictures here, we have a rusty propeller, we have a steel bolt, we have a pipe which looks like it has some rust on the outside, and what looks to be like an engine. And all of these things have one thing in common: they're all brown, they all seem to have missing material somewhere, and this is most likely due to the environments that they are exposed to. This propeller usually would be in salt water, ocean water, and this pipe would possibly be underground where it can be moist. This engine would most likely be in maybe like a car or a boat that would have a humid or moist environment around it, and whatever this bolt may be screwed into could possibly be exposed to harsh environments as well. So how does corrosion happen? So corrosion occurs when cations on the surface of a metal, in the example to the right here we have iron, react with oxygen in water to form certain oxides. In this case, iron oxide, which is Fe2, 3 plus, and O3, 2 minus. So this iron 3 oxide then forms on the surface of the metal, leaving behind pitting or degradation, and hydroxides in the water, which can turn it basic and cause pollution. So in this example, we have this site right here where Fe, or iron 2 plus cations, left the surface of the metal, entered into the water, reacted with oxygen, and formed on the surface of the metal as this brown product, which is our iron oxide. And then of course this electron had to go somewhere, so it jumps to the other side right here, and that's how we get those hydroxide ions. So this is going to highlight a very important problem that we spend lots of money on per year to try to prevent. We have issues with corrosion and how it can compromise the structural integrity of whatever boats, planes, cars, or buildings we may have.
The structure on the left shows a very clear sense of corrosion resistant measures that have been taken, while the structure on the right does not and could possibly have had that protection eroded away. Here are some of the types of measures we can take to prevent corrosion. 1. Using metal alloys to prevent building degradation. 2. Polymer coating for electrical equipment and components. 3. Galvanization for most types of rails and railings. And 4. Cathodic protection or sacrificial layers to prevent corrosion against direct sea contact like the bottoms of ships. In this picture, it shows the bottom of a ship, and I think it's pretty important in the shipping industry to use alloyed steel for the bottoms of boats so they can prevent against corrosion. Through the use of alloyed steel, we're able to create corrosion-resistant ship bottoms or ship materials. The reason why this is because we mix trace amounts of elements like chromium, magnesium, nickel, and molybdenum to create these alloys, mixing in the steel. When this happens, and we use these steels or they're exposed directly to the high salination content of the water, we are then able to see that the protective layer is then formed using these trace elements and protects the inner layers from corrosion.
Next is polymer coatings. They offer an additional defense against corrosion as they are easy to use and can be applied to alloyed steel. These coatings, which can be made from various polymers such as epoxy, polyurethane, and more, create another physical barrier that prevents moisture and corrosive substances from reaching and interacting directly with the metal. By sealing off the underlying material, polymer coatings not only prolong the life of the structure, but also reduce maintenance costs over time because they become an external hull, taking the hit instead of the more expensive metal. For example, epoxy coatings are frequently applied to pipelines and storage tanks to prevent rust and degradation inside of them, while polyurethane coatings are used on steel structures and equipment exposed to the extreme conditions of being outdoors in the humid weather, providing much longer lasting protection.
Galvanization is one of the other popular methods of protection against corrosion. It is a finishing process that adds a thin layer of zinc onto the outside of the metal in order to assure that it acts as a sacrificial anode. The steps of hot-dip galvanization include cleaning the metal in order to assure that no dirt, sand, or grease is left on during the process. Fluxing then adds a thin layer of zinc ammonium chloride in order to assure that the molten zinc bonds to the metal more easily. Once the fluxing is dried, it is then hot dipped into molten zinc at 4,500 degrees Celsius in order to form a metallurgic bond. Once the bond is formed, the metal is then cooled to room temperature, which then it is finished with another layer of zinc or is sent off to be shipped to the manufacturing company. One of the benefits of galvanization is that it is very low maintenance in the way that it does not need to be regularly maintained over the time period. It is also cheaper considering that zinc is very common in the earth. One of the cons of galvanization is that it only lasts up to 50 to 100 years due to the zinc beginning to corrode away and then corrosion then eating away at the metal inside. Cathodic protection is the same concept as galvanization, where electrons will flow from the zinc to the metal. The zinc then becomes a sacrificial anode, while the metal is protected and becomes a cathode. The difference between cathodic protection and galvanization is that the sacrificial anode is easily replaceable, while the zinc on galvanization is bonded to the metal itself. Sacrificial anode cathodic protection has the zinc directly attached to the metal or through a wire in order to have the constant flow of electrons. Impressed current cathodic protection, or better known as ICCP, is a method that has a generator that connects the zinc to the metal. The generator allows the flow of electrons to be more controlled and stable, rather than sporadic. One of the pros of cathodic protection is that it is often long-lasting and easy to replace. However, the cons is that both need to be high maintenance by keeping the generator up and running or having to replace the zinc every once in a while.
And these are our references where we have gathered all of our data. Thank you for listening to our presentation, and I hope you have a good rest of your day.